Today on Coding 101, your Python list example, we're going to explain Heartbleed with jelly beans and a while loop.
Nom 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 nom.
Nom, nom, nom.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode is brought to you by lynda.com. Learn what you want, when you want, with access to over 2,400 high-quality online courses and training videos, all for one low monthly price. To try it free for 7 days, visit lynda.com/C101. That's LYNDA.com/C101.
Welcome to Coding 101. It's the TWiT show where we introduce you into the wonderful world of the programmer. I'm Father Robert Ballecer.
And I'm Shannon Morse, and I'm eating jelly beans. They're stuck in my mouth right now, and I can't barely talk. But we're going to teach you all about coding for the next 30 minutes so that you can become a Python code warrior.
Now, Shannon, in the last couple of weeks, there's been a big thing that's erupted throughout the interwebs. And that's all about Heartbleed, right?
Yeah, they broke my heart.
They did. So later in the show, we're actually going to give you an in English, honest to goodness, easy to understand example of how the Heartbleed bug works. But before we get there, you know what? We always start the show off with some examples, yeah?
That's right, we do. So last week we covered lists. And lists are surprisingly very easy to write and kind of fun, actually.
Yeah.
So I had a lot of fun writing mine. I'll go ahead and pull up my example so you can see how I wrote it and what it does. So if I click on it, double click, and you'll probably have to zoom into this because it's a little small, but it basically says, who doesn't like Star Trek, right? My Star Trek captains are my favorites in order: Picard, Janeway, Kirk, Sisko, and Archer. And my favorite Star Trek series in order are The Next Generation, of course, TOS, Voyager, Deep Space Nine, and Enterprise.
By the way, awesome code, but totally inaccurate list.
What?
Totally inaccurate list.
Please,
Seriously,
why?
that you would put... no,
Okay,
you know what?
first
No,
off,
we're going to take
Picard,
this offline.
he's number one.
Okay, I
He's
will give
number
you
one.
Picard, but Janeway? Janeway?
Come on, she speaks to me. She speaks to me.
Mm-hmm.
She's a woman in power, and I like that. Kirk, not so much. He's a total man. He's a womanizer.
He's a womanizer.
That's exactly what it is. And then Sisko and Archer, they were kind of...
Now, last week, you flipped that. You had Archer ahead of Sisko, and I was like, no. Sisko can't be at the bottom.
Well, I like Deep Space Nine more than Enterprise.
Right.
So it made more sense.
Okay, I'll give you props for that.
Yes, so that was my example, and for that code, this is how I wrote it. So I had print who doesn't like Star Trek, and that's just a simple print screen. And then I made my first list, which is Star Trek, Picard, Kirk, Janeway, Sisko, Archer. Now you'll notice that this list is a little bit different. This is in order from the original series all the way to the end. So when I printed that, I had to shift it around just a little bit to make it from my favorite to my least favorite. So I started with 0, which is Picard. Number 2, which is Janeway, and then once I scroll over, you'll see 1, 3, and 2.
There we go. And
1,
see,
3, and 4.
Actually, that's a great example of one of the powers of lists, which is once you have your data in there, you don't have to follow the stream of the original data. You just give it the index for what position you actually want to use.
Exactly. I did pretty much the same thing with series. So I named this list series equals, and then I put the original series, Next Generation, and so on and so forth. And then I printed my favorite Star Trek series in order are, starting with series number 1, which was TNG, series 0, the original series because it's so awesome, and so on and so forth. And then at the end, since I'm on a Microsoft computer, I put raw input, press enter to exit.
And that's just so it maintains the terminal window until you actually want to exit. Now, something else, I love this, I love that you did this. You use a descriptive name, and this is one of the things we really need to hammer into our audience, which is, you can name your variables anything. You can name your list anything, so why not give it a meaningful name? In your case, you called it by series. So people can say, oh, yeah, the variable name, the index name, the list name actually makes sense.
Exactly. It made sense, so that's why I decided to name it that.
Woot.
Now, we also got a really excellent example of a list from Daryl Medley. So this is called a shopping list. If I double-click on it, it simply says, enter the name of item 1. So this is going to be my shopping list. So I'll say, I need to buy milk. How many quantity? Just one, because it'll spoil, because I'll never go through it. Number 2, I of course need cereal, and I'm gonna buy 5 boxes of cereal. I go through that like crazy. Number 3, I need some towels for my downstairs guest bathroom.
Always have a towel.
So I press enter when finished, and it takes my list, it takes these things up here, and outputs them to me. So I have milk, quantity 1, cereal, 5, towels, quantity 3, plus enter to close.
Now this is pretty good, but I'd say if it was going to be customized for you, it would have to be a coupon list.
It would have to be.
It really would have to.
It would have to have some math in there for me.
There we go.
I should do that.
Good. I like this one. This is great.
So if we look at the example, I'm going to edit it with idle. Now I'm zoomed into this because we had a little problem seeing all of it last week. So if I scroll down, you'll see.
First of all, I love the comments. Thank you for the comments.
Excellent comments.
We love that.
Thank you so much, Daryl. So once I scroll down, you see shop list, and then we have case list, item count. So first it prints shopping list, prints the other information, and then we do a loop. So this is pretty interesting. He added a loop in there. How fun. Now we're going to get more into loops in just a few moments, I think so. But
you're spoiling it.
Oh, I already told them in the cold open.
Okay,
Gosh.
fine.
And then we have some if and whiles in here, some options. So a lot of this looks a little bit confusing, but it won't soon. So we'll explain all of this. But this
so
is
obviously he knows
example.
a little bit of Python beyond what we've shown on the show.
Exactly.
But none of this is really beyond anything we've given them.
Right.
There's a little bit on the conditional modifiers here, the conditional operators. But beyond that, this is just a print. This is just a loop. This is just a list.
It's so pretty.
It is pretty.
It was very easy to understand, and
very
he made
well done.
lots of comments in here. So I
who was this again?
to show it. Daryl Medley.
Daryl, give yourself a pat on the back. This is definitely the program of the week.
Thank you, Daryl.
Thank you, Daryl.
So that was my example of a list and Daryl's example of his own list with loops. Yay! Now I know that we have tons of splaining to do.
Yeah, we do got some splaining. Okay, so we do want to go back into loops. Now, I'm assuming that many of you watched our C# module, and if you have, you know what a loop is. A loop is just a really simple way to repeat a section of code. Now, the reason why you want to repeat sections of code is, well, if you're doing the same operation over and over and over again. Like, for example, if you just wanted to print a series of numbers, you don't want to have to do print variable 1, print variable 2, print variable 3.
It would take too long.
It would just take, and it's just silly, right? Because it's always the same line.
Yes.
The only thing that changes is the name of the variable. Well, what a loop allows us to do is it allows us to minimize the amount of coding that we have to do by saying, repeat this with this difference. Right,
okay.
so just keep doing the print.
It sounds similar to a list, but in this case, you're changing the variables up at the top.
Right, and it allows us to just keep doing the loop until we want to stop.
That's cool.
It's a very good way to be efficient with your code, and also it's pretty much the only way to do a modern program. If you don't know loops, you can't write a modern piece of code, because otherwise your code would be just pages and pages and pages long, and we don't want that.
With no comments.
With no comments, yeah. So that's what loops do. Now let's take a look at how loops actually work in Python. One of the things you have to remember is while loops in Python actually aren't all that much different from the while loops we did in C#.
Okay.
Now, they use some sort of counter because you need some way to determine whether or not the loop is going to continue to run, right? So you need a condition. You need something that says, when you check this, if this is true, continue to run the loop. If it's not true, break the loop.
Break the loop, yeah,
right.
Or cancel it.
Yeah, and do you remember from C# what happens if you don't have that in there?
It just keeps going and going
right.
and going.
Exactly. If there is no way to change that condition, that true or false condition, then either the loop never runs or the loop runs forever.
Yep.
So we have to have some sort of variable, some way, something that changes in the processing of the loop that allows us to change the condition of whether or not the loop can run. Does that make sense?
That does make sense.
Okay, so let's actually look at some code. Brian, if you go ahead and switch to my screen, I've got. This is probably the easiest.
That's a simple one.
This is a super simple while loop, okay? So all I do is I have a counter. I have a variable, it's set to 0.
Okay.
Okay, so counter is equal to 0. That's a number. Now, the while loop itself is counter less than 5. That's my condition. That's my relational condition.
I see what you did there.
Exactly. So counter is set to 0, right?
Right.
So while 0 is less than 5. Is that true?
Yes.
Okay, exactly. So it's going to run.
So it'll run.
And then the next line is counter equals counter plus 1.
And then it equals 2.
Well, first it equals 1, and then it equals 2, and then it equals 3, right? Because it starts at 0, right? So we're starting at 0, and yeah, that's just an increment. So all it does is it adds 1 to the counter every time it runs, and then that third line there is print, and all it does is it prints. Now let me show you really quickly. There's an indentation. You see this right here? This is actually important. This is not a throwaway thing.
Yes, I do see that.
This is how Python, if you remember from last week, this is how Python knows that this code, this counter equals counter plus 1 and print counter, belongs to the while loop. It's because I've indented it.
So can I just hit tab whenever I'm typing the code?
Yes, absolutely.
Okay.
You can tab it. Right, and this goes for every other, if you were to put a while loop within a while loop or an if-else statement inside that loop, you would also have to indent it. So just remember, it's like old school math where you just go one column over every time you have one operation nested within another.
Okay, that makes sense. It keeps it organized too.
Right, so let's go ahead and run this, and what we get is this. 1, 2, 3, 4, 5.
Cool. Yeah, that's super simple and very easy.
Exactly. So it runs it until I get to the end. And at the end, it gets to 5, and it's going to say, is 5 less than 5? And the answer is no. And it stops.
Okay.
And that's it. Okay? So very, very simple program. That's how a while loop works. And that's what we're going to be doing for the rest of our time today.
Perfect. Okay.
However, we gave you the while loop.
Yes.
There's a little something else we want to talk about.
Yeah, there is. It's kind of going a little crazy on the internet.
It's going a little crazy on the internet. We got heartbleed.
Uh-oh.
Yeah.
I don't have any heartbleed.
No, you don't. No, you're good. You're good to go. But what we want to do is we want to talk about heartbleed because it actually addresses something very, very basic in programming and something that's very important. It's all about sanitizing inputs. It's about
sanitizing your comments.
Well, sanitizing your code.
Yes.
You have to make sure that the data that you receive is what you expected.
Exactly.
And unfortunately, the writer of the piece of code in OpenSSL that is responsible for the heartbleed bug didn't do that. Now, Brian, you actually have a link for the GitHub that has all the OpenSSL code. While you get that up, let me really briefly state what's going on in the heartbleed bug. So what we're talking about is the heartbeat. Anytime I established a secure connection, so Snubs, let's say that you're Facebook, okay, you're the Facebook server. I'm talking to you. You know how you get that little padlock in the upper corner of your browser? It tells you that you're secure, right?
Yeah. It tells me I'm using HTTPS.
Exactly. I've Secure Sockets Layer or TLS, which gives me an encrypted tunnel between the client and the server. You're the server, I'm the client. Now, that's a good thing, because without that, anyone could just snoop in on our conversations and they could read everything that I'm sending and everything that you're sending back to me.
Especially if they have a Wi-Fi pineapple.
Brought to you by Hack5. No, but see, here's the thing. I can't just keep those open. Right? Once I've established one of those connections, I need a way to tell the server that even when I'm not using it, let's say I'm reading something that's on my page and I'm reading it for 3 minutes, my client, my computer, still needs to be able to tell the server, I'm still connected, I still need you, don't shut off the connection.
So this is the heartbeat that's going between us.
Right. It's a nonsense piece of data. It's a minimal data set. It's a very small handshake, very small packet, essentially saying, keep me alive.
Okay.
Keep me alive. Keep me alive. And it does that every once in a while.
So why do we have these jelly beans up here?
Okay, so this is your system memory. You're the server, right?
Oh, yeah.
Don't eat your memory.
I won't eat my memory.
I'm just going to eat all the memory. All right, so
my hard drive just failed.
Now this one jelly bean, this is my heartbeat packet.
Okay.
Okay, so what I have to do is I have to send you two things. I have to send you my payload, and the payload is the jelly bean, right? But I also have to send you a description of how big this is.
Ah, okay.
So in all non-open SSL implementations of SSL, of the secure sockets layer, of the encryption, whenever I, the client, send something to you, the server, you check what you received against what I told you I sent.
Ah, okay.
So let's say I do this. I go ahead and I say, I'm sending you one jelly bean. I give it to you.
I just received one jelly bean.
Right, and that's it. And so you said, well, you told me that you sent me one jelly bean. I read that
it looks like a jelly bean.
It looks like a jelly bean, and now you send it back to me.
I'm sending you one jelly bean.
And there we go. So now the connection stays alive. If I did this, I am sending you 5 jelly beans, and I give that to you. What do you think you as a server do?
I only have one jelly bean.
That's it, right?
This is odd.
This is odd. It'll kill the connection, right? Or it'll ask for the heartbeat again.
Right.
That's simple checking, right? That's sanitizing your inputs. That's making sure that you've actually received what you expected to receive. That's good coding.
That makes sense.
That makes sense.
Yeah.
There's a bug in OpenSSL.
No!
Yeah. And Brian, if you go ahead and bring up that GitHub, it'll actually show you the code that goes behind SSL. Now go ahead and forward, what line was that? We need you to go to line 3972. There, right there. See, so you see where it says read type and payload length first. These next 4 lines of code, actually 3 lines after the comment, are entirely responsible for the heartbleed bug. Now let me explain. This looks kind of crazy, but let me explain what's here. HB type is just setting the type of data. Okay, so that's like from C# that just says this is the kind of data I'm going to be receiving.
Okay.
P++, we've seen that. It's incrementing the counter. So it's P plus 1, right?
Plus 1, yeah.
Now here's the big line. NS2, which is calling a function, because we know it's in parentheses, right? So it's calling a function, and it's passing it 2 parameters. P is the location, it's called a pointer, of the payload, the jelly bean. So it's telling it where the jelly bean is located.
Okay.
Right? Payload is the length. That's me telling you I'm passing you 1 jelly bean.
Ah.
Okay? Now a good piece of code would have had an extra line here that says, is P, the length of P, equal to the length of payload?
Right, yeah.
Right? So if I told you...
It would be sanitizing their
It's
code.
sanitizing the code, sanitizing the input. It's saying, if I told you I'm giving you 1 jelly bean, what is P? How long is P? Is P actually 1 jelly bean? If it is, allow it. If it's not, then X. Kill the connection.
And since they didn't do that, there is no line that says if it's this long, then it should equal P.
Right.
That pretty much means that the payload could be as long as they want.
Or short. So this is how it works. If you come back to me, now we're talking about this jelly bean, all right? So I'm still talking to you in the server, and I'm passing you this 1 jelly bean, and I'm saying, I sent you 64,000 jelly beans.
It looks like 64,000 jelly beans.
That's how OpenSSL works. Because it doesn't check, it's just going to trust me. And unfortunately, that's not good. So what it's going to do is it's going to say, well, he must have sent me 64,000 jelly beans, so I'm going to send him back the 1 jelly bean plus 63,999 jelly beans he shouldn't have received.
So
which means I take your system memory.
Hello, hacks.
And it's all for me.
Oh, that's bad.
Hello, hacks, exactly. and see, the problem with that is they can do it over and over and over, and each time they'll get a different set of the memory until they can put it all together, and they can essentially have everything.
And from the server end, everything looks cool, so nobody ever checks for any difference.
To the server end, if you're using OpenSSL, the unpatched version, all it knows is that someone's sending a lot of heartbeats. And that's normal, because that's how we keep the connection open. It doesn't realize that it's giving away the keys to the kingdom every time it sends you that 64K.
Authorization acknowledged.
Precisely, exactly. We got a computer fault. So that's how Heartbleed works. And go back to that code, Brian. This is the crazy part. This is what we're trying to drill into you people. When you're writing your code, you got to make sure to check for things like that. This was an innocent mistake. This was, again, we know that this was submitted something like, what was it, an hour or 2 before midnight 2 years ago, December 2011.
Right.
So it was probably some guy staying up late, writing some code. It looked right, it worked right, but he never actually made sure that he was receiving what he was supposed to receive.
Oh man, I feel bad for that guy.
I feel bad for him, but you know, simple mistake that anyone could make.
Yeah, it's true.
Yeah.
That's unfortunate, but it's a good example of what can happen if you don't sanitize.
Very good example, yeah. Which brings us to this part of the show where we're actually going to bring someone in who has experience with sanitizing, right?
But before we do that, I wanted to tell you guys about a website that I really, really enjoy and I've been using for years. It's called lynda.com, and they are our sponsor for today. So if you haven't checked out lynda.com yet, it is a website where you can get everything that you ever want as far as thousands of online video courses in software, creative, and business skills. So whether you want to learn to write Python code, or you want to explore the foundations of programming, or improve your photography, everything like that. With a lynda.com subscription, members receive unlimited access to thousands of high-quality and engaging video tutorials across a wide variety of subjects. Now here's a cool one. Do you ever want to build your own iOS app, but you're not a programmer? Well, lynda.com has a new course called Programming for Non-Programmers, iOS 7. This is so cool. It'll allow you to build your first iOS app in a single afternoon. You'll learn the most important concepts in iOS and the app development process. By the end of the course, you'll have a finished app That's awesome. And a basic understanding of Xcode, the tool set for developing iOS apps. You'll know the building blocks like variables and functions and conditional statements and interface design. And you can find links to this course and many more over at lynda.com/C101. So I used lynda.com for years. I used it for everything from learning how to use Adobe Photoshop, hey, photography, and even Premiere for when I was, helping Paul over at Hack5 learning how to edit back in the day. Long time ago, but you know what? All of those little tidbits that I learned from lynda.com still work today.
You know what I love about this is we get a lot of people who are asking us, well, when are we going to actually get to do some app development?
That's true.
We don't need to do that. Because what we're doing is we're teaching people how to code. We're teaching them the fundamentals. And then they can go to something like Lynda and they can look at the iOS development lessons and say, oh yeah, this makes sense. Now that I know how to break down problems into computer code, I can just follow these steps and make myself an app.
And you know what? Maybe you don't want to learn Adobe Photoshop, but guess what? There's 2,400 courses online and more are added every single week. So you're going to find something that you like, trust me. Lynda.com courses are produced at the highest quality and they're not homemade videos on YouTube. So you're going to get good audio, good viewing of the people that are doing the show. Everything that you need is right there. The instructors are accomplished professionals at the top of their fields, and they're passionate about teaching. So you're not going to get somebody who's boring, which happens a lot. You're going to get somebody who is excited about what they're teaching, and that's what I love about doing videos on lynda.com. Courses are for all experiences, whether you're a beginner, intermediate, or you're advanced, and you can watch on your computer, your tablet, or your mobile device. So if you're on the go, like I do, I'm commuting often, I can watch them via my cell phone. It's perfect. Now, whether you have 15 minutes or 15 hours, each course is structured so you can learn from start to finish. You can even search the transcripts to find quick answers, or you can read along with the video, which is super helpful to me if I'm not paying that much attention. Lynda.com offers certificates of completion when you finish a course, so you can publish to your LinkedIn profile, which is great if you're a professional in a certain field. That's really fun. Now, it's only $25 a month for access to the entire lynda.com course library, or for $37.50 a month, you can subscribe to the premium plan, which includes exercise files that let you follow along with the instructor's project, using the exact same project assets that they do. And you can try lynda.com right now with a free 7-day trial. Visit lynda.com/C101 to access the entire library. That's over 2,400 courses, free, for 7 days. Have at it. I mean, do this, go at it when you're on your spring break. Watch all of them.
This is a perfect summer project. If you're coming home from high school, if you're coming home from college, why not use Lynda to brush up on some of the things that you really, really want to learn?
Exactly. And again, that was lynda.com/C101. And of course, we thank lynda.com for your support. We love you guys. Thank you.
Woot. Lots of woot.
I think it's time for some Code Warriors.
I think so. Now, it'd be great if we had someone we could bring in right now and maybe have him explain how while loops and code sanitization and input sanitization works in the real world.
Who could that be?
What's up, guys?
It's Dale Chase from Discovery Digital Networks.
What up?
How you doing?
Doing good. How you doing?
Yeah, so, Heartbleed, huh?
Oh, yeah, no kidding.
Well, I've got something here that will at least show you how to, I've got a couple of examples here. One sort of simple one that will let you sanitize positive integers that you're just looking for.
Ooh, okay, this looks kind of complicated.
Not so much. Really, I mean, it's really just a while loop. So let's go through it. So I start here by saying clean equals false. Clean is what I'm going to be using to set up my while loop.
Okay.
And to check the state of that. So I'm starting it off as false.
And I like that because you're assuming that the input coming in is wrong, and you want the code to say it's wrong until it proves otherwise.
Right. Yes. So I'm saying while clean is false with the double equal here. Phones equals, so here's the first input, how many phones have you broken?
You jerk.
Now we know from the ivory tower that because those lines are indented, they belong to the while loop. So the while loop will continue to repeat everything indented over up to that print statement.
That's correct. Then we go into how many laptops have you dropped with another raw input command, being assigned to a variable called laptops. And then if phones.isDigits is digit, this is a function that will now assess what is in phones and make sure that it is a positive integer, essentially.
Okay. So that's a function. So phones.isDigit means that I'm taking the variable called phones and I'm running the function isDigit against it. And I'm assuming that since the makers of Python used functions with understandable names, all it's going to do is look at the variable called phones and say, is this a positive integer?
That's correct.
Okay.
I'm also doing that for my laptops variable as well in the same if statement. And I'm making sure that condition happens together with this and. I think in C# that's like an ampersand.
Right. Ampersand. So it's saying if this and that are true.
Exactly.
That's cool.
Yeah, in Python, you actually can use the real word and so then that is now part of so that if statement. If that is true, if both of these are positive integers, clean becomes true. And the loop stops.
Right. Now let's point out something else here. We did this in previous episodes, but if you look at the while loop and if you look at the if statement, both of them have a colon at the end of the line. Now we told you that Python only cares about white space. It actually looks at formatting. However, anytime I'm doing one of these statements, one of these functions that use multiple lines, I have to have a colon there to tell it, hey, you're about to get multiple lines. So that's all it means.
See. Okay.
Yeah, that's
you're
why
not done yet. Here's
I'm
the
not
rest
done
of the
yet,
code.
right? Which is why for while it says continue to do the rest of the code that you're going to see indented, and in the if statement it's going to say continue to do the rest of the code that you're going to see indented. That's all it means. That's all it means.
Cool.
So since everything that you input with raw input is actually taken as a string, I still have to tell it that phones is an integer,
right,
and laptops is an integer for me to actually do this math here where I'm going to add both of these together and then print out the total.
Right.
Okay.
And what he's saying is, remember, because Python, as we talked about in the first episodes, the variables are dynamically assigned, right? In C# we had to tell it, this is an int, this is a float, this is a character, this is a string. Python doesn't do that.
You don't have to do that.
You don't have to do that, except when you start doing, if you go back to his code, when you get to that line where you actually want to use numbers, you need to make sure that Python has converted that into numbers. Otherwise, it's just defaulting for a string.
Okay, got it.
Yeah, what it'll actually end up doing is just concatenating the two numbers together to make a long number that you didn't ask for.
Right.
So let's run this, I guess.
Yeah, let's do it.
Let's see. Do I have it here?
It's here somewhere.
It's a sanitizing input. All right.
Whatever I named it this week.
There it is. There it is.
Okay. How many phones have you broken? 12.
That's later. That's later. Okay.
How many laptops have you dropped? 2.
Really? Just 2?
Wow.
That's pretty good.
Way to go, Dale.
Yeah.
And my total is 14.
Okay. And that's basic. That's simple.
Real quick.
But let's run it again, because what we want to check is we want to see if the program actually knows whether or not it's been given the right information.
Right.
That's right. So here we go again. How many phones have I broken?
Jelly beans.
Yeah, jelly beans. Absolutely.
Jelly beans. Oh.
Just like that.
How many laptops have
And let's actually give it a number. Let's say, how about just 5? Let's see what happens. Oh, so we're mixing inputs.
Yep. How many phones have you broken?
Oh, so it asks you again. It's like,
Yeah, so remember back to the code. Actually, go back to the code, Brian. Oh, actually, I'm sorry, Dale, if you could go back to your code. Yeah, So what's happening, it's stuck in that while loop because it never cleared it, right? Because in the if statement, it says both of these have to be true. In the example we gave it, only one was true, and so therefore it failed the and statement, and so clean was never set to true.
So I guess one thing that I could do, if I wanted to, under if, I could add an else statement that said something like, if this is not actually a integer digit, then I could say that's wrong. Yeah. Put in a number.
Hey, what are you doing? Get that out of here. Exactly. Yeah. Okay. I mean, this is a simple program, so we didn't do that. But you're exactly right. Yeah, you could have an if-else statement. Yeah. And an if-else statement, all it says is, if this is true, then do this. If anything else, if it's not true, then do that.
Ah, cool. Okay.
But where you go?
I get it. I get it.
Very nice, Snubs.
I'm learning.
How about
print?
So else. Hey. So you're gonna just print out a statement that says something like, "That was wrong." Oh, so you also had to add that slash, so it knows that the.
I'm escaping the apostrophe.
Yeah, the apostrophe there is.
I could get around that by actually using double quotes instead.
Right.
Oh, okay.
Right. There we go.
That's not a number. What you doing?
Go ahead. Yeah, go ahead and run that. Run that bad boy. And now if we put jelly beans in there.
Let's break that. All right. Jelly beans and tacos. Oh, wait. What happened? It didn't...
Oh, no. Oh, the terminal window was still running. It never...
No. It was. I ran it again. It should have taken.
The else.
Oh, did I not save this? Oh, this. Oh, I didn't save this in the right spot.
Dale.
Got some explaining to do.
Yeah. Now this is basic sanitizing. I mean, now of course, what the guy who wrote OpenSSL, that module, what he had to do was far more complicated than this.
Right.
But the theory is the same thing. You always need to make sure anytime you're dealing with any sort of input, any sort of data, that it's acting the way you want it to behave.
Right.
If you don't put a check, you can get bad things.
And that's what we get. Okay, so now it says print, hey, that's not a number, and then it asks you again. So it redoes the loop.
Right.
Cool.
Because remember, we told the loop to run until it got 2 valid inputs.
Right, that makes sense. That's awesome.
Yeah. Now, Dale, let's go back to your code for a second, if you could. The pieces that our audience need to know, the pieces that they need to learn because they're new for this episode is they need to know the while loop. They need to know the function to actually check the data. So is digit. And, well, they need to know if else. We're actually going to go more in depth on that next week, but it's actually not that difficult to figure out. And the last part is they need to know the function for int, which actually turns that variable into a number.
Laptops.
Okay. Right.
Now, notice he has the int function to turn those into numbers. He has that after it's already checked the strings to make sure that they are numbers.
Yeah.
Because you can't actually run that if someone gave you a string. You can't say, turn jelly beans into a number. It will freak out.
Ah, okay.
Yeah.
Now, I also noticed with is digit, that can only work for positive numbers. So is there an option up there if you wanted to put in a negative number or something else?
There is. If you want to, you actually kind of have to get into a little bit of a try except, which is sort of error handling.
Oh, interesting.
Yeah. So yeah, in Python, there is no real easy way to sanitize without doing that. But yeah, so let's pop this up here.
Yeah, it's not built in, but you can sort of code around it.
That's
yeah. Cool. So let me pop this up here. Oh. Yeah, that's what I'm gonna do.
Yeah, yeah. Now, Dale, while you're working on this, one of the things that we'd love to talk about is, obviously, you have to do these sort of data checks, these sort of variable checks when you're coding in the real world. Do you have a good example of a time when people didn't properly sanitize their inputs and it led to some bad things?
Oh yeah. Well, or a situation where you definitely want to have your input sanitized, where if you're accepting an email address and they put a comma in front of the com instead of a dot in front of the com for the email address, and then they won't get their email notification. So you want to make sure that when they enter the email address, they are actually putting in a valid email address that you can then communicate with them with.
Right.
I guess it could also be said that if you have a text field like that on the internets anywhere where they say enter an email address and it doesn't check to make sure it's an email address, they could put another line of code in there.
Yeah.
Yeah.
And actually, we just had a example of that. You may have read that the quote-unquote ATT hacker was let out of prison, right? They dismissed the case. Well, he didn't really do any hacking. All he did was he took advantage of some very sloppy programming that didn't check the input. It didn't make sure that it was receiving any input that it couldn't either properly process or would process in a way that they didn't expect.
Right.
So, I mean, we see, it sounds really simple. And, you know, when we look at the code that created the Heartbleed bug, we say, oh, God, you know, why wouldn't you do that? But it happens over and over again, folks. So all we're saying is please, 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 even in these starting days when you're just starting to pick up the compiler, make sure you get in the habit of checking your code. And you know what? We're going to say this. In future episodes, when we have your user programs, we will favor the ones that have some sort of sanitization.
Ooh, yes.
Does that make
sense? I'll have to start checking for those when I'm looking over the code on the Google Plus community. Now, before we finish up, Dale, I did want to check out that code that you just put in.
Yeah, let's take a look at it. So here, you know, it's pretty much the same up until we get to now where the, what was that? So now instead of is digit, instead of an if statement asking if, you know, if it's a digit, we get a try, which is try to convert this string into an integer.
Right, right.
If it fails, it will throw an exception, and the type of exception it will throw is a value error. So if that happens, then we'll print, hey, you didn't give me a number.
Right. So essentially, instead of running it through a function beforehand to make sure that it's an integer that it can use, you just ran it through the integer conversion, and if it gave you an error, then you know it wasn't an integer.
Exactly.
Got it.
Exactly. And I could have saved a step later in the print statement and just used phones if I had just decided to actually assign these integers to phones. If I decided just to say phones equals in phones. I could have done that and saved having to do it down here. But I didn't.
But either way works the same.
Yeah. Cool. Yeah, so and if they do pass that test, we go to else and clean becomes true and the loop stops.
Fantastic.
That's awesome.
Dale, thank you so very, very much. It's always great to have you as our code warrior. Now, Brian, our TD, can you give us a little bit of a groove so we could play Dale out? Because Dale, we want to give you your time here. I mean, you've given yourself selflessly. Can't talk today. To our audience, and where can they find you? Where can they find your art? Because you're not just a programmer, right?
I'm a musician too.
Yay!
And yeah, I've got a song with Shannon that you might know called SSH to Your Heart. Right now you guys have up a Coder Girl remix, which you can find at dchase.bandcamp.com. Among all my other stuff, and what you've got there is Love Plus Plus, which is my most recent EP, which I released on Valentine's Day. So
and you
it's
actually
sort of
did several songs with one of the lovely ladies that works at Hack 5.
Yes, Sarah, she's awesome.
Yes, Sarah.
Yeah, and so Love Plus Plus is like a companion piece to my most recent full-length Type Def, which I released around this time last year, actually.
Oh.
So yeah, check me out on Bandcamp at dchase.bandcamp.com.
Yay!
Yay, that's right, folks. He's a programmer, he's a geek, he's a musician, he is a Renaissance man. Dale Chase, Discovery Digital Networks. We'll see you next week.
Thank you, guys. Catch you later.
Thank you, Dale.
Now, Shannon, that was a lot, right? I mean,
that was a lot. That was a lot of information, but it was really good information to get out there, especially about sanitization.
Yeah. And, you know, it's one of these things that people always think, oh, I'm not going to get caught by it. Everyone gets caught by it.
Right, exactly.
I'll say it right now. If you are not actively searching for values you did not expect, you will be caught by this bug at some point in the near future.
There's somebody out there who's fishing through all the websites looking for people who didn't sanitize
and they
their
probably
code.
have a pineapple on their shirt.
They probably do.
They probably do. Now, we don't want to just leave the folks thinking, oh gosh, this fire hose of stuff coming to my head. We have show notes, right?
We do. They're over at twit.tv/code, C-O-D-E. That's where you can find the show notes for every single episode that we do, even our old ones from C+ as well. And you can also find our GitHub link on there.
Which, by the way, I understand we are having an issue right now. I'm not sure exactly what's going on, but the revisions I'm making are not making it into the GitHub. I may have to recreate it. So if you've bookmarked that GitHub, please go back into the show notes and get the new link to make sure that you're getting the one that's being updated.
Right.
Also, don't forget that we're on iTunes. Go ahead and jump into iTunes if you're an iCoder and help us spread the word about Coding 101. Believe it or not, we're still one of the most downloaded, subscribed to podcasts. We want to keep that going. We want people to understand the world around them, and that means they're going to have to learn how to code. So go tell people.
No, wait, people are watching this show.
I know, weird, right?
What? That's crazy.
Oh, no.
People are out there?
I know, behind the camera.
That's so weird. Well, if you are out there, hi. We're also on YouTube. You can find us over at youtube.com/twit coding101. And that's where you can find all sorts of information about us and all of our YouTube episodes.
That's right. And also, we've got a G+ community, and it's vibrant. I am absolutely convinced we're going to...
I love the code that we're getting on our
that's where we pull the stuff. So if you want your code featured, you got to go to our G+ page. I know we're going to break 1,000 subscribers before we hit the end of this module. And you can find us at gplus.to/coding101.
Oh my gosh. We are at currently, where's our numbers?
Boom, 815.
That's awesome.
And you know what? If you are the 1,000th code monkey, code warrior, code person to join our community, I will send you an autographed Python compiler.
What?
I know, it's free.
We could send an autographed picture.
We could. We don't have
They printed pictures for us.
They did?
Well, I
didn't
got
get
some.
any.
I could send you an
I'll sign one of Snub's.
You could sign one of me.
Also, if you're not into the G+ groove, you can find us on Twitter. We're both on Twitter. We're both pretty active. And you can ask us questions there, or you could ask us about guests that you might want on our wildcard episodes between modules. You can find me at twitter.com/PadreSJ. That's at PadreSJ.
And I'm at Snubs.
Yeah. And don't forget, you can watch us each week at Thursdays at 1:30 p.m. Pacific time. If you come to live.twit.tv, you'll see the pre-show, you'll see the post-show, you'll see all the foibles. It's actually a lot of fun, right?
It is super fun. And we also listen to you guys in the chat room. Hi, everybody.
All the time, yeah.
irc.twit.tv, so you can chat with us during the show if you have questions.
Until next time, I'm Father Robert Ballecer.
I'm Snubs.
End of line.